I'll try to make this short and sweet. So I build gadgets, and I've been lucky enough for a number of years, DARPA has been interested in some of these gadgets, been good for me. So I thought I'd very briefly show you the kind of stuff we've done, kind of to draw some inferences and some inside baseball maybe at the end, and then kind of wrap up. But I should tell you, so I think of DARPA as a very well-intentioned, reasonably wealthy, mildly medicated schizophrenic uncle. And so, you know, because I've been doing this for more than a decade, and so I think that model, then we'll get into something more, you know, maybe more mature, but that model tends to work for me as transitions go on in DARPA. And, but there's always well-intentioned, very intelligent uncle. All right, so I think the first DARPA funding I ever received was with my advisor, Roger Howe and Jay Kiesling, where we really wanted to aggressively miniaturize microreactors for fermentation, instrument them, bring a lot of these sort of technological innovations that were happening in sort of micro and nanofabrication and apply them to sort of this biochemical problem. And the reason I'm bringing that up is that I think that went through the chain of events that you all have been talking about, which is to say that we did good work funded by DARPA, and then it became a company. It was commercialized by two talented individuals, Dave Klein and Stephen Boyer, and then it was sold off in 2009. That company was Microreactor. And so that began this was a few years ago now, began my sort of obsession with what is really what I do for a living now with my group, and that's gadgetry at the interface of biology and sort of the synthetic. And my obsession, for good or for ill, is that when I look into the future 50 years, I have drunk the sort of George Church Kool-Aid, which is that in many, many decades, we will really see this the bringing the biological to technology. Alicia Jackson has been talking about this for a while. And where it interests me is that I think that if that is true, we will need these interfaces between the things that humans have built with this, call it synthetic or whatever technology we have now, and this organic stuff, right? Nature has not evolved turbines or radios or anything like that, and I think the fusion of this is a very interesting space. So let me tell you about some of the zanier things. I'll point out, I think you'll see maybe where I came up with the statement before. And then all I want to do after I show you some of these fun gadgets, hopefully fun, is a couple of slides on what I have learned. A lot of this I think you've already heard. So I think, let's see, where do I start? One of the zanier things I think DARPA's ever funded was the idea that you could, or they asked a question, which was rather controversial actually, and I'll get to that later. Could you take a living insect and implant it with radios and neurostimulators and neuromuscular stimulators, or whatever you wanted really, and could you fly that little insect around like an airplane? Could you use it as a nano-air vehicle? In fact, it does work. We built these things and we flew them around and had demos and stuff like that. And so this was quite an interesting sort of process to go through all of this from the sort of science to the engineering. More recently, you're about to hear, I think, the next talk from Edward Chang, who's going to talk about this very amazing and sort of ambitious project in which we play a small part in the sense that we developed technology to do wireless microelectrocortical recording. And that was now playing a role in the subnets proposal through a company called Cortera that we founded with Jan Rabai and Ricky Muller and Peter Luderhovitz and other people. And so this was also really worked its way into the goals and visions that DARPA is pushing in neurointerfaces. And these days I do, in fact, quite a lot of neurointerfacing stuff. I really believe that's one of these areas where this hybridicity is going to be a big deal. We, about a year and a half ago, put out this idea, and now, thankfully, working with DARPA on this, wherein we suggested that there's been this sort of amorphous idea or this sort of vague dream in the area of people doing neuroelectrophysiological recording that one day you'd be able to miniaturize everything and shove it into brain tissue and sort of RFID out information from the brain. Wouldn't that be great? We could, there might be advantages to this. And we started by showing that we didn't really believe using RF that was possible for very fundamental reasons. And after we sort of laid out the math for why that was, we then pointed out that there was an unexplored area where you could build something like this using ultrasonics. So you could build very, very, very fine ultrasonic objects, 100 microns on a side is sort of the goal. This is what we call neural dust, which you can couple energy to, and they will use that energy, record locally, and then backscatter communicate through the ultrasonic signal. We're building these. We're using them in peripheral preparations right now, and it's looking really good. And so what else do we build? I think you can see that there'll be a point to showing you all these things in the next slide, sort of the very first one. But I'm very sort of omnivorous. This is about to come out into press. This is sort of wound monitoring technology. We have a lot of stuff that looks at how cells respond to biases, electrical biases, and so on. And I think to wrap this part up, the craziest, I think, blue sky thing we're currently working on in my lab is to hybridize CMOS with bacteria that have been hacked by Adam Arkin and Carolyn Aho Franklin. This is an approach to building sub 1 millimeter scale sort of hybrid biological and synthetic biobots, basically, where we have particular pathways put in, Adam's and Carolyn's work in the biological substrate that allows us to do some really cool things in tandem with the electronics, and the electronics takes advantage of all the amazing super low power, infinitesimally small. I can exist without a battery because I'm harvesting from the environment, that kind of thing, and putting it all together and showing that you could build a hybrid at that scale to do things that you can't do with a purely non-cellular object. So if you care about any of this, feel free to come ask me. What do I take out of this? I think a couple of key points. You probably have heard all of these, but I think they're worth emphasizing. For me, DARPA is omnivorous and agnostic. I mean, they just care about what will get to that vision that they have. And I find that incredibly refreshing because there's no sacred cows. I think the insect project for me, for good or for ill, that project is a bit controversial, but it showed that they were capable of saying, look, we want to look at this. We want to really, who can pull this off with whatever technology? What's the answer? And I think that is, for people like me, and I think hopefully for all of you, that is really, really, really refreshing to deal with. They take humongous risks on ideas and people if they believe in them, and they can move fast on them. I've never noticed any preloading. This is sort of maybe too blunt to say anything, but I have never noticed anything like that. And in fact, the beauty of it is I can write a 2-page white paper and send it out, and I know that I will get back like pretty quickly, or I'll get something like, wow, okay, we didn't know you cared about this area. What about this? And then quickly you have a conversation, and that's amazing to me. You can't do that with any other agency that I know of. And this has already been said. When you hook your schizophrenic uncle, he's like, whoa, that's a good idea, kid. And then, and he gives you a suitcase. And then you're like, wow, this is amazing. And then but then he starts bothering you like every day. What about now? What about now? What about now? And I'm like, dude, you called me 2 days ago. What about now? But it works. I'm very, alpha plus, and so that works for me because you feel like, you're like, ah! So I'm very happy with that model. I shouldn't tell you guys that, but it's true. So my inside baseball are these 4 things. These are pretty pictures from Neural Dust, but I think what I learned early on is appreciate the DARPA mission statement. I think if you take the time, I know this is really sort of almost like a platitude, but ask your program manager or anybody you talk to tell you what the DARPA program mission statement is, right? Avoid technological surprise, so you can internalize that, and then you realize why you pitch or package the things you do in the way you do, because this is really important. I also find that trying to pitch why they should give you money is much less effective than explaining that you have a real vision that could change something, and it can involve everyone, right? This is a big deal, I found. You sit there and you go, look, this is not about you giving me $200,000. This is a big deal, and everyone can play. My idea is so big, everyone can have fun in my sandbox. And if you think about it that way, I think you find that you're very, very receptive to the idea. The last one I think I've said, swing for the fences and they'll give you a huge suitcase. And the last one is, and this is going to sound like I'm blowing air up into the people over here, and of course I am because I'm a smart individual. But no, the point is that I've always found every PM and all the SADAs to be very, very sharp. I pride myself on thinking it once or twice I have, but I've rarely passed through any BS through their filter. And so I'm proud to say that makes it for a very good collaborative, when they do call you every 2 days, it's usually with something intelligent. Usually. Okay, thank you. I believe that's all I have to say.